All right, so now on for the lesson. What we're going to do is I've put the link in there in your assignment for today. When you click on it, remember to hit sign in with ClassLink. It will automatically sign you in. And then yours is going to look a little bit different than mine. So you would click on your assignments, and then you're looking for lesson two, searching for common ground. And I'm going to go ahead and I'm going to view that. And guys, just a reminder, I am giving you grades for these. So if you're not doing them, you will be getting zeros until they are completed. And May 21st is the last day that you can turn in any late or missing work. So I just wanted to make you remind you of that because I was grading last night and there's some that still have not completed this. All right, so we left off on question 26. And then I've also had some people get on. I did have somebody have questions today. And after I finished testing, I hopped on Google Meet and we worked through those questions. So like I said, as soon as I finish testing, I run up to my office and I check any assignments that you may have commented on so that I can help you. And I will get on Zoom Google Meet, and I will help you. No worries there. Okay, so this is the last one that we did was this question 26. So we're going to move on to questions 27 and 28. So we want to look over here. So suppose we want to determine the common factors of 56 and 42, but we don't have a grid paper to create rectangles. Is there another way? Okay, so what they did is they went ahead to determine one way that they did this was they determined the common factors and they used prime factorization. So they started writing each number as a product of its prime factors. So they went ahead and created factor trees. They didn't show those here, but I'm going to go ahead and show you just so that you can get them. So for 56, I'm going to go ahead and do a factor tree. I know that the two factors that I can multiply together are 2 and 28. Okay, 2 is prime, so I'm going to circle that. And remember, prime is the number, the only factors that it has are 1 and then the number itself. All right, so now I'm going to factor out 28. So I'm going to go ahead and I know that 2 can go into 28, and 2 times 14 gives me 28. So 2 times 14 gives me 28. 2 is prime, and I circle my primes. They drop theirs down. I like to circle mine so that I know that's what I'm looking for. And then my last one right here, we have 2 times 7, because 2 times 7 is 14, and 7 and 2 are prime. So now let's go ahead and do our factor tree for 42. Again, you do not have to start off with the same numbers that I do. I'm going to choose to do 2, and then I know that 2 times 21 is 42. 2 is prime, and then 3 times 7 is 21, and 3 and 7 are prime. So if you look in this example right here, they went ahead and they placed this in a table, and I wish I could move it over. Let's see if I can make it. Oh, there we go. So they went ahead and they took their prime factorization. So this is 2 times 2 times 2 times 7, and then 2 times 3 times 7. So here, 56, we have 2, 2, 2, 7, 2, 2, 2, 7. Here we have 2, 3, and 7, 2, and notice they skipped those because 56 only has 1, 2 in common. Then there's the 3, so the 3 right here, and then the 7. So this is a very good representation of how we can now look to see what they have in common. So 56 has this in common, the 2, and it also has the 7 in common. Okay, so that's what they did. They used the factor tree to create this this chart, the table. Okay, so then we can easily see. The common factors of the two numbers are the numbers that are in both rows and the product of the numbers that are in both rows. So 2 and 7 are factors, but then also to find the last one, we would multiply the common factors together. So 2 times 7 is 14. So we know that the common factors of 56 and 42 are 2, 7, and then we multiply those together and we get 14. So 2, 7, and 14. So I'm going to go ahead and I'm going to erase this so that we can go ahead and type in our information. And you're going to type this with me because you're going to be completing this and I'm taking it as a grade. So the first question says, how do we know that 14 is a common factor of 56 and 42? Well, we know that we can take 56 and we can divide it by 14. If I can find my division. Let's see, is my division in here? Divide, divide, divide. Do you see it? I don't see my division symbol. I guess I can put this one. I thought it would have a regular division symbol. So I'll just put this. So we know that 56 divided by 14 equals 4. And then we also know that 42 divided by 14 equals 3. So we know that they're divisible because if the result in both cases is an integer, and remember integers are those whole numbers, they're opposites, and the divisor is going to be a common factor. Okay, so when we're finding those common factors, we know the ones that are in the inside of this table right here. So the 2, the 7, and then how we got 14 is we would take those common factors in the table and multiply them. So 2, 7, and 14 are common factors of 56 and 42. Okay? So number 28, why is there a space between 2 and 7 in the top row of the table? So they're talking about this right here. Why does it go 2, 2, 2, and then there's a space and there's a 7? So what I want you to do is I want you to write your answer in the space. Tell me why there is a space right here between that 2 and that 7 in the top row of the table. All right, so the next thing we're going to do is we're going to consider the numbers 54 and 84. So before I fill out my table here, I'm going to go ahead and I'm going to do a factor tree because that helps me figure out my factors. So I'm going to go ahead and I'm going to get my pen and I'm going to do 54 first. So I've got 54. Again, I'm going to go ahead and do 2 and 27. 2 times 27 is 54. 2 is prime, so I circle it. And then I'm going to do 3 times 9. 3 is prime because the only factors I have are 3 and 1. And then 9 is 3 and 3. And I'm going to go ahead and I'm going to circle those. I'm going to switch colors just so we don't get confused so that I can do a factor tree for 84. So for 84, I'm going to decide to do 2 times 42. Again, you may have chosen different ones. You could have started off with 4 times 21, and that's fine. The end result will be the same. And then 42, I'm going to do 2 times 21. 2 is prime. And then 3 times 7. So now what I need to do is I need to go ahead and put in my answers for 54. So I'm going to go ahead. So I've got 2, 3, 3, and 3. So I'm going to go ahead and just put them straight across. 2, 3, 3, and 3. I may have to adjust them. So I do have a 2 right here, but then I can't put this 2 here because we want them to line up. So it looks like I'm going to have to go ahead and push this one back and move it back because there's a 2 here. But then I do have a 3, so I can put my 3 in there. And then I have a 7. Well, there's no 7 in the 54, so I'm going to have to move, and there's only one 3 in common, so I'm going to have to move back. I'm going to have to do a 7 back there. So then now there's my table of prime factors, and we can see that 2 and 2 are common, 3 and 3 are common. So 2 and 3 are common factors, and then we said if we multiply them together, so 3 times 2 is 6, so we'd have 2, 3, and 6 as our common factors for 54 and 84. Okay, so I'm going to go ahead and go to the next one. So I want you to go ahead and identify all of the common factors of 54 and 84, which we just talked about. We have 2, we have 3, and if we multiply them together, we get 6. So the common factors are 2, 3, and 6. So you will type that right here. Okay, the common factors are 2, as we can see right here, 2, 3, and then we multiply those together and get 6. So then of those common factors, you are going to put which one is the largest. So we just talked about the 3 common factors of 54 and 84. You are going to write which factor is the largest. So now we're going to rewrite the sum using greatest common factor, and we're going back to that distributive property. Okay, so we're going back to that distributive property. So what we can do is we know 56 and 42. So we're going back to, let me go back to it right here. Oops. Oh no. Sorry, guys. So we're going back to this one, the 56 and the 42. We said that the common factor, the greatest common factor, the biggest one was 14. So that is what we are going to pull out, okay? So that was the greatest common factor, the biggest number that was a factor of 54 and 84. We said there was 2, 7, and then we multiply those together and get 14. So what we're going to do is we're going to go ahead and we're going to pull that 14 out. We're going to put the parenthesis. And then what we're going to do is we're going to, if we pull that out, because we know 54 divided by 14, that gave us 4, plus, and then if we did 84 divided by 14, that gave us 3. And we just got those numbers. We already did the work. It's right here. 56 divided by 14 is 4. 42 divided by 14 is 3. So 14 is the common number that goes on the outside. And then 4 plus 3 is what goes on the inside. And that's what we're getting ready to type, 4 plus 3. Okay? So there's that one. So identify all of the common factors of 80 or 54 and 84. So, yeah. Oh, sorry. No, it's the next one. You already did this one. Sorry, guys. You did the largest one. Here it is. So we pulled that 14 out, and then we got that 4 plus 3 because we did the division on it. There. Sorry about that. Okay, so there's that one. So this is the distributive property. The greatest common factor is 14, and then when we divided each of those by 14, we got 4 plus 3. So what I want you to do is I want you to try this one right here, the 54 and the 84. If you need to, you can go back. But we already know that our common factors were 2, 3, and then we multiply 2 and 3. So the highest common factor is 6. Okay, so there's our 6 times. Now we would have to do 54 divided by 6, which is 9, because we're going to do 6 times 9, which is 54, plus then your 84 divided by 6 is 14. Because then if we use that distributive property, 6 times 9 is 54, plus 6 times 14 is 84. All right, let me go ahead and clear this off because it's a bit cluttered. All right, so now what we're going to do is we're going to switch gears and we're going to actually talk about common multiples. And when we talk about multiples of a number, we're talking about if we were to count by the number. So example, the multiples of 2 would be 2, 4, 6, 8, 10, 12, okay? So we can use rectangles for this as well. So here's an array to determine the multiples and common multiples. Consider this that it's 6, 1, 2, 3, 4, 5, 6 by 8. 1, 2, 3, 4, 5, 6, 7, 8. So a multiple is the product of a given number and another whole number. One way to think about the area model is to analyze the collection of columns. The addition of each new column creates a multiple of 6. So for example, this first right here, the first column is 6 times 1. We're just looking at this first column. 1, it would be right here, and 6. Okay? Then it would be representing the first multiple of 6 or 6. So it would be like counting 6, 12, 18. Okay? The first or the whole rectangle represents 6 by 8, which the entire area is 48. So the first thing that we're going to do is we're going to list the first 8 multiples of 6, okay, by labeling each column of the area model. So columns are up and down. So we're going to go ahead and we're going to label these. So we're going to count by 6s until we get 8 rows of them. So I'm going to write them here. So I have 6, and you're going to do this eventually, or you're doing it with me right now. 6, 12, 18, 24, 30 would be this one, 36, 42, and then 48. Okay, then what it's going to ask you to do, and I'm going to do this all on one just to make it easier, okay? So now they're going to ask you to go the opposite way. So to count by 8 all the way down. So we have 6 rows, we're going to count by 8. Here we go. We have 8, we have 16, we have 24, we have 32, we have 40, and we have 48. So in just a minute, they're going to ask you, looking at these multiples, what is the greatest common multiple of 8 and 6? So if we look to see which one they have in common, that is the largest number, they're going to ask us that question. So we may have to come back to this, okay? So now we're going to think about the area rectangle model, which we did this. We went ahead and we did this going down this way. So if you do it on this one, I will count that. So 6, count multiples of 6 going across, multiple of 8 going down. If you do it on one, then you will not have to do it on this one as well, okay? So now we're going to talk about the commutative property of multiplication. So it just states that if we have numbers A and B, that we can multiply A times B or B times A. So for example, we could have 2 times 6, which equals 12. Well, the commutative property says that I can also switch those numbers around and do 6 times 2, and that gives us 12. This is the commutative property of multiplication. That's all it says. If we multiply 2 times 6, it's the same thing as 6 times 2. So while 48 is a multiple shared by 6 and 8, it's not the least common. So let's go back to this. Our common multiple is 48. So it's 48 in here. But we're trying to find the smallest one, the smallest multiple of 6 and 8. So if we do that, I can see that we have 24 right here, and I also have a 24 right here. That is the smallest multiple of 6 and 8. So the least common multiple of 6 and 8 will be 24. Okay, so that's what they're getting ready to talk about. So right here, we know that the least common multiple of 6 and 8, when we looked at our grid, was 24, because it was the smallest number that both of them had in common. Okay? So as demonstrated by the rectangular array, we know that we can change the number. So again, 2 times 6 is the same thing as 6 times 2. It'll give us the same number. All right, so what I want you to do is I want you to go ahead and we're going to do this together. We're going to list the first 9 multiples of 6. So we're going to count by 6s 9 times, okay? So 6, 12, 18, 24, 30, 36, 42, and 48. Now we're going to do the same thing, but we're going to list the first 6 multiples of 9. So we're going to count, oops, I missed one here. It's going to be 54. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to the first 6 multiples of 9. So I'm going to count by 9 6 times. Okay, so I have 9. Make sure you're also following along and putting this in. 9, 18, 27, 36, 45, and 54. Now what I want you to do is I want you, looking at these multiples, I want you to write in for C, what is the smallest, the least common multiple? So what is the smallest number that 9 and 6 have in common? Okay, put that in there. I'm not giving you the answer. Okay, so now what we're going to do is we're going to determine the multiples of 7 and 8. Okay, 7 and 8. So what I want you to do is we're going to go ahead and we're going to list the first or the multiples of 7 8 times. So I'm going to do this up. Actually, I'm going to do it here. So I'm going to go ahead and list them. So 7, 14, 21, 28, 1, 2, 3, 4, 35, 6, 42, 49, and then 56. Okay, so there's those. Now I'm going to do my 8. So I'm going to do the first, so 8. I'm going to do that 7, the first 7 multiples. Okay, so 8, 16, 24, 32, 40. Sorry, lost track. 1, 2, 3, 4, 5, 6, 7, 8. 48, 56, 64. Okay, so now I want to go ahead and I want to find my least common multiple. So what number they have in common that is the smallest? Go ahead and put your answer right here. Okay. So now we're going to use prime factorization. And using prime factorization, how can you determine whether the least common multiple of 2 numbers is the product of 2 numbers or is less than the product of 2 numbers? So when you do the other ones, the 2 least common multiples, and you finish this, you're going to see that if the 2 numbers that are given to you have a greatest common factor, so using that factor tree and table, other than the number 1, the least common multiple is less than the product of the numbers. Otherwise, it is the product. Okay, so you're going to notice that when you start working out those problems. Okay, make sure you type that in. I'm doing these with you. Okay, so we have another worked example. So they went ahead and did 56 and 42. So this is the same thing that they gave us before. And they said that our common factors were 2, 7, and then we multiply them and get 14. So now we're going to do the same thing for 12 and 10. Okay, so when I do my factor trees, and I can do those for you real quick if needed. So I have 12 and I have 10. So I'm going to do 2 and 6, and then 3 and 2, and then 3 is prime and 2 is prime. For 10, I'm going to do 2 and 5, and that's all I have. So now I'm going to switch back, and I'm going to go ahead and I'm going to do my my table. Oops. Okay, so the first thing that they asked for is the product. So what is the product of 12 and 10? Well, if I multiply 12 and 10, because product means to multiply, I get 120. Now I'm going to go ahead and I'm going to fill in my table. I'm going to put my common factors. So I have 2, 2, and 3. So I'm just going to do 2, 2, and 3. I may have to adjust them. So here I have 2 and 5. So I can put a 2 here for 10, but I can't put the 5 here or here because that's not in common. So I have to put it all the way out here. Okay. So now they're asking, what is the least common multiple? Okay, well, what we can do with that is we could go ahead. Actually, did they ask for the greatest common factor first? No, they didn't. Why is that? Okay, there's that. Product, yes. Okay, so let's do the greatest common factor first. So our greatest common factor, I hate this, sorry guys. We've got 2, and that's it. Okay, so our greatest common factor is going to be 2. So we're going to put that in. Then we need our least common multiple. And instead of writing down all of those multiples of 12 and 10, we can use this chart. Okay, so what we're going to do is we're going to multiply all of the products that they have in common, or all of the numbers factors that they have in common and ones that they don't. So for example, to find the least common multiple, we're going to go ahead and we're going to take 2 because that's in common times 2 times 3 times 5. So all I'm going to do is I'm going to take each of those factors and multiply them, and that will give me my least common multiple. And then that way I don't have to write and write and write and write and write. I don't want to have to do all the multiples of 12 and 10. So when I multiply those together, 2 times 2 is 4. 4 times, I'm going to do 4 times 5, so 4, and then 4 times 5 is 20, and then 20 times 3 is 60. So I was able to get my greatest common factor, which we said is 2 because that's what it has in common, and then my least common multiple by using this table and multiplying 2 times 2 times 3 times 5, and we know that it is 60, and I didn't have to write all of them. Okay, so let me go ahead and clear this. I want you to go ahead and I want you to try this one on your own. So you're going to find the product right here. So you're going to multiply 9 and 15 and put that there. You may need a piece of paper to do your factor trees and then complete this right here, your common factors, just like we did in the table. If you need help, look over here. And then I would do your greatest common factor first, and then your least common multiple. And you actually have 2 of them to complete. Okay, so actually you have 3 of them to complete. Okay, actually, well, let's do this one together. We'll do this one together real quick. So my product of 5 and 9 is going to be 45. Okay, and they've already done the table for us. So if we notice right here, 5 and 9, 3, 3, and 5, or sorry, 3, 3, and 5, nothing is in common. There's nothing in the table that shows in common. So that means that our greatest common factor will just have to be 1. So if there's nothing in common, our greatest common factor will just be 1. Okay. And then the least common multiple, I'm going to go ahead and I'm going to take all of these numbers and multiply them. So 3 times 3 is 9, and 9 times 5 is 45. And if you notice, the product is 45. Okay, so the product, when I multiply those together, there was 45, and my least common multiple is 45, and that happens, so the least common multiple and the product, they're the same when our greatest common factor is 1, and that's always going to be true. So we're going to go ahead and we're going to write a sentence to describe the relationship between the product of the greatest common factor and least common multiple, which we just talked about. We just said that the least common multiple is multiplied by the greatest common factor is equal to the product. That's one thing that can happen. Another thing that can happen is we are also going to notice that the product divided by the greatest common factor is equal to the least common multiple. And the last thing that we may decide to do is that the product divided by the least common multiple is equal to the greatest common factor. Okay? So now we're going to consider the sum 36 plus 24. We're going to go ahead and we are going to write that using the distributive property. I'm going to do one, you're going to do another. I am going to decide that a common factor of 36 and 24 I know is 2. Okay. So I just went ahead and I can show you that in the factor tree, I know that a common factor of 36 and 24 is 2. Okay? Because I can take 36 and divide it by 2, and I can take 24 and divide it by 2. So then my parenthesis, if I divide that by 2, 36 divided by 2 is 18. And then I would add that to 24 divided by 2 is 12. So I have done 1 for you. I would like you to do B. So find another common factor. There's more than one. And you are going to write the common factor on the outside, and then take that common factor, divide 36. That's your first number, plus take that common factor, divide it by 24, and that's your second. So if I go ahead and multiply this out, 2 times 18, because this parenthesis means multiplication, that is 36, plus 2 times 12 is 24. So you're pulling out that common factor, and then in the parentheses, you divide 36 by the common factor and 24, and that's how we get the number inside. Okay, so the next thing I want you to do is, can you always determine the greatest common factor of any two numbers? Okay, so I want you to answer this question. Can you always determine the greatest common factor of any two numbers? And I want you to explain how or why you can or cannot. Also, I want you to, there was that special word, if the greatest common factor of two numbers is 1. So we talked about this. What can you say about the numbers? Okay, we talked about something, a specific thing. It was called relatively prime. If the greatest common factor of two numbers is 1, what can you say about the numbers? Well, numbers are relatively prime, so that would go here. Then, can you always determine the least common multiple of two numbers? I want you to explain your reasoning. If yes, why? If no, why? If the least common multiple of two numbers is the product of those numbers, what can you say about those two numbers? Okay. If the least common multiple of the two numbers is the product of those two numbers, what do we know about that? We did an example like this. And then once you're finished, you're done. Okay, so you had a total of 49 questions. We worked through some of them. You're going to finish up this lesson, and then I will look it over once you finish it, so probably on Thursday. Okay, so you're doing 27 through 49 today. Okay, that's all you're doing. You're finishing up that lesson, and then I will get an assignment for you on Thursday. All right, guys, so if you need me, drop me a line in the Google Classroom, and then I will look at that and I will see if I can hop onto Google Meet tomorrow if you have questions. Again, I'm grading these, and some of you have not even done that. You haven't even done any of the lessons or the warm-up. So you will be getting zeros, and the last day to turn in work will be May 21st. All right, guys, if you have questions, send me a message, and I will see you later.